Collins Maths Frameworking 3.3, book 3.3, 8.5, the difference of two squares. The difference of two squares. Let's look at the examples here. Example A is x squared minus 16. So difference means one take away the other. I've got 6 to each, you've got 4. What's the difference? 6 take away 4 is 2. The difference is 2. So here we have one thing take away the other. That's the difference. And this is a square. It's x times x, x squared. And this is a square, 4 times 4. Okay? So one square take away the other. That's how we get the expression difference of two squares. And we're going to factorize this. But how do we do that? Because previously we do the x times x and that gives us x squared. We do the number times the number, that gives us the number. X times the number and the x times the number. And then that gives us the bit in the middle, the plus 4x or whatever it might be. There isn't one here. Well, there kind of is, but the coefficient is 0. So exactly the same rules apply. We haven't changed anything at all. Same rules apply. What multiplies to make 16? 1 and 16, 2 and 8, 4 and 4. Now look, it's negative. So that means one of the pair is going to be negative. Okay, so we then need to add them up to get the 0 that's you can't see because it's 0. So minus 1 plus 16, no. 1 minus 16, no. You can probably see that if we were to have minus 4 plus 4, that would give us 0. X, there's the x, there's the x. Minus 4 plus 4. Easy. The example B is a little bit more tricky. 5x squared minus 20. Straight away I'm like, well, that's not a square. Yes, there is a square root of it, but it's weird and complicated, not a nice number. It's the x on its own, yeah, the x squared, no problem. But with the 5 in front, no. And the 20, we can't easily, with whole numbers, get a square root from that. So, yeah, what do we do? Well, let's get rid of that 5. Let's take that 5 out. 5. If we take 5 out of the x squared, sorry, if we take 5 out of the 5x squared, we're left with x squared. If we take 5 out of this, remember we have to take the 5 out of that as well. Minus 4. Ah, that looks more familiar. We have a square minus a square. So now we have to have the 5, then our two sets of brackets. And when it's the difference of two squares, we end up with 1 minus 1 plus. So two numbers that multiply together to make 4. 2 and 2. And if one is negative, one is positive, that way we get rid of the plus 2x squared minus 2x, sorry, plus 2x minus 2x, they cancel to nothing. So we're just left with the x squared minus 4. Okay, I'll kind of stop there. Go ahead and do the exercise. I'm going to help you with question 5, but I'd like you to have a go. People struggled with this exercise, so have a go, but I will help you with question 5, but pause, do it yourself first. Okay, here we go, question 5. Believe it or not, that's a square, should be. Side B and B, B times B. So the area of this is B squared. We're going to call that a little square. So this is a piece of card, and we've cut out a little square, area A times A squared. So the question is what is the area of this piece that's left? Yeah, it's a funny shape. We can't do what we did at primary school and split it up and into other rectangles. It's B squared minus A squared. But the question says, show that the area remaining show that the area remaining is B plus A, B minus A. Show that. Okay, so what we're going to do is we're going to start with a different expression for the area. The area of the green is the big square minus the little square. Okay, so we're going to now factorize that. Now, a lot of people are like, whoa, freaked out here because there's no number. Well, don't be freaked out. Same rules apply. Well, we're going to have a B here and a B here, because those then B and B multiplied to make the B squared. Now, these two numbers, except they're not numbers, they're going to be letters, they're going to multiply to make A squared. What two letters multiply to make A squared? It's A and A, isn't it? But then they've got to add together to make hang on. When we do our smiley face, remember, B times B, B squared, A times A squared, okay. But then you've got B times A, AB, and then A times B, AB. They've got to add together to disappear. So if we just make 1 minus, 1 plus, let's expand it and see where we end up. So it equals B times B, B squared, and then B times A, positive, good. Keep them alphabetical, and then we've got minus A times B, minus AB, and then minus A times plus A is minus A squared. And look, plus AB, minus AB, they disappear. So you can see how factorising the difference of two squares gives us that. Okay.